How do I prevent overfitting in CNN image classification? Imagine training a model so well that it memorizes every tiny detail of your training images, but then struggles to recognize new pictures. That's what overfitting is. When a convolutional neural network learns the noise and specific quirks of your dataset instead of the general patterns, it performs poorly on new data. To stop this from happening, you can use several proven techniques. First, data augmentation is a simple but powerful method. It involves creating new training images by flipping, rotating, zooming, or changing brightness and contrast. This makes your dataset more diverse and helps the model learn features that are more general and less tied to specific images. For example, if you have a small set of pictures of cats, flipping or slightly zooming them can help the model recognize cats from different angles or lighting. Next, dropout regularization is very effective. During training, dropout randomly turns off a percentage of neurons in the network. This prevents the model from relying too much on any one neuron and encourages it to learn more robust features. Usually, dropout rates of around 25 to 50% are used, depending on the model size. Early stopping is another handy technique. While training your CNN, you monitor its performance on a separate validation set. When the validation error starts to rise, it's a sign that the model is beginning to memorize the training data. Stopping training at this point helps keep the model from overfitting. Regularization techniques like L2-weight decay also help. This method adds a penalty to large weights in the network, encouraging it to keep weights small and simple. Smaller weights often mean the model is less likely to fit noise and more likely to generalize well. Batch normalization is another tool in the toolbox. It normalizes the inputs to each layer during training, which not only speeds up learning but also acts as a regularizer. It helps keep the network stable and prevents overfitting caused by internal covariate shift. Adjusting your model architecture can also make a difference. Using a simpler model with fewer parameters or specialized modules that capture features at multiple scales can reduce overfitting. For example, global average pooling layers can replace fully connected layers, reducing the number of parameters and helping the model focus on important features. Transfer learning is a popular approach, especially when your dataset is small. Starting with a pre-trained model that has already learned general features from a large dataset, and then fine-tuning it on your specific data can significantly reduce overfitting. This way, your model benefits from prior knowledge and requires less data to perform well. In the world of artificial intelligence and machine learning, preventing overfitting is key to building models that work well on new and seen images. It ensures your CNN learns the right features without getting distracted by noise. This is especially important in applications like medical imaging or autonomous vehicles, where accuracy and reliability are critical. When you use techniques like data augmentation, dropout, early stopping, regularization, and transfer learning, you create models that are both powerful and dependable. These methods help your CNN focus on the real patterns, making your image classification tasks more successful and trustworthy.